Good morning all. I am Babita from BBRITH. Today my topic is potentiometer. So what is a potentiometer? Potentiometer is an instrument which is used to measure the unknown EMF by comparing with the known EMF. The known EMF will be supplied from the standard cell or any other reference voltage source. So how to measure the value of unknown EMF? Unknown EMF value will measure by using the balance conditions. So potential, when we'll get the balance condition is when the galvanometer shows the null deflections. So this is the circuit in which we connected the two cells. One cell whose EMF is known, another cell whose EMF is not known, or which is to be measured. In between we connected a galvanometer. So when the galvanometer shows the null deflection, that means the potentiometer is in balance conditions. So we'll connect the cell in such a manner that the both cells of the same polarity will connect together. So there will be no circulating current in the circuit. So when there is no circulating current in the circuit, the galvanometer shows the null deflection. That means the potentiometer is in balance conditions. So there are different types of potentiometers like AC potentiometers and the DC potentiometers. So what is the difference between AC and DC potentiometers are? DC potentiometers are used to measure the EMF of the battery, whereas AC potentiometer is used to measure the magnitude of the battery as well as the phase angle. So there are different types of AC potentiometers are. AC potentiometers are like Drysdale tensile polar potentiometer and the Gall tensile coordinate potentiometers. What are the applications of AC potentiometers are? AC potentiometer used for the self-inductance calibration of voltmeter, ammeter and wattmeter. There are different types of DC potentiometers are like Duran, slide wire and Crompton's DC potentiometer. So applications of DC potentiometer are measurement of current, high voltage, resistance, power, and will use for the calibration purpose of voltmeter, ammeter, and wattmeter. I'm going to tell in detail about the Crompton's DC potentiometer. So what Crompton DC potentiometer consists of it? It consists of the two sliding contacts P1 and P2. P1 will slide over the wire, slide wire AC, and P2 will consist of the n number of coils which is connected in series with the AC. And we'll use one battery B to provide the current in the circuit. And we'll have a two resistance R1 and R2. R1 will show the coarse adjustment and R2 will show the fine adjustment. And we'll connect one galvanometer and switch between the P1 and P2 in series with the multiple circuit switches. So what is use of multiple circuit switches is with the help of the multiple circuit switches, we can connect at the same time the standard cell and the unknown EMF, and we can measure more than one unknown EMF. So standard cells will connect between the S plus and S minus, and the unknown EMF will connect between the 1 plus and 1 minus or 2 plus and 2 minus. So before we will go to measure the unknown EMF of the cell, we go for the standardization of the potentiometer. So what is the standardization? Standardization is the process of adjusting the working current to match the voltage across the slide wire against the reference voltage source. So first the potentiometer has to be standardized. So we'll standardize by using the standard cell whose EMF is known, that is 1.0186. So 0.0186 will be adjusted by the P1 and the 1.0 will be adjusted by the P2. So after the standardizations, we'll switch the K, we'll close the switch K, then current will start flowing through the circuit and the galvanometer start deflecting. So to get the null deflection, we'll adjust the value of R1 and R2 in such a way. R1 will adjust the core adjustment and R2 is fine adjustment to get the null deflections. So when you get the null deflection, that means it is in balance condition. Now we'll connect a battery whose EMF is to be measured between the terminal 1 plus and 1 minus. Now after the connecting the battery whose EMF is to be measured, then we'll adjust the P1 and P2. We'll adjust the P1 and P2 again in balance, which gives the reading of the EMF of the battery. So in this manner, we can measure the unknown EMF of the battery. So what is the drawbacks of the Crompton DC potentiometer is, whenever we'll measure the unknown EMF, we'll go for the re-standardization, which takes a lot of time, and to balance the conditions. So this is the major drawback of the Crompton DC potentiometers, and the application of DC potentiometer in real time is used for the voltage divider in electronic circuit, used in the radio and television receiver, for the volume control, tone control, etc., and used in the medical equipment also. Thank you.